of the early applications of integrals is to find the average value of a continuous function on a closed interval. And this application is an application of definite integrals. Now, if it's been a while since you've done work with definite integrals, make sure that you look in the description of this video for links to my videos on evaluating a definite integral. If you've just come from working with definite integrals and you're ready to get on with the process, continue on with me and we'll see this application. So the average value of a continuous function on a closed interval is actually denoted by f sub avg for just the initialization of average, and you're looking at the average overall output of the function over that interval. And it's defined to be 1 over b minus a, where a and b are the endpoints of your closed interval, times the definite integral from a to b of f of x dx. Now, I do have an earlier video where I went over the mean value theorem for integrals, as well as how that links up with the average value of a function. So I'll put that link to that video also in the description, so that if you want to see why this is the way that they've defined it to be, you can go back to that video and refer to that. But for us, we're just going to look at examples. And so here the first one is find the average value of f of x equals 3x squared plus 1 over the interval from 0 to 4. So basically, I'm just going to run the values that I have and the function that I have through that formula. So my average value of my function is equal to 1 over, well, remember, a and b are your endpoints of your integral. So you're going to go b minus a. So 1 over 4 minus 0 times the definite integral from 0 to 4 of your function 3x squared plus 1 dx. So again, it's a continuous function, and then I have it on the closed interval. Now, this definite integral, 0 to 4 of 3x squared plus 1 dx, that's a number. I just have to figure what that number is. And then in the front, I have this number, so I just need to do the calculations to find the numerical value. So this gives me 1 over 4, and then evaluating this definite integral, remember you find an antiderivative for the integrand, and we're going to just look at each of these term by term, find your antiderivative, and then after we find an antiderivative, we're going to plug the top limit of integration through the antiderivative minus the lower limit of integration through. Because our, again, definition for our definite integral from a to b of f of x dx, we did learn by the limiting process, but then by the Fundamental Theorem of Calculus got that if we can find an antiderivative of f of x, it's just evaluating that antiderivative of the upper limit of integration minus evaluating that antiderivative at the lower limit of integration. So that's what we're going to use here. Now, what is an antiderivative of 3x squared? Well, add 1 to the exponent and divide by that. That would be 3 over 3, or 1, x to the third. And then plus an antiderivative of 1 with respect to x is x. And we're evaluating from 0 to 4. So our notation now, we did our integration, but we still need to plug in our endpoints, and that's why we have that vertical line reminding us to do that. So this is 1/4 times, plug in the upper limit of integration, that's 4 cubed plus 4, and then minus plugging in the lower limit of integration, so 0 cubed plus 0. And while I'm plugging in 0 to a polynomial and it doesn't have a constant term, I'm just going to have a 0 for this, but I want to make sure to show that that's what we would do if we didn't have 0 that we were plugged in. Okay, so then this gives me 1/4 times, well, 4 cubed is 64, plus 4 is 68, and then minus 0, so 68, and then 1/4 times 68 is 17. So my average value of f of x equals 3x squared plus 1 over the interval from 0 to 4 is 17. Let's do part B. Part B says find the average value of the function f of x equals x squared plus 1 on the interval from -1 to 2. So again, my average value of my function is 1 over b minus a, so 2 minus -1, times the definite integral from -1 to 2 of my function x squared plus 1 dx. So now, simplifying each of this, my average value of my function is 2 minus -1, 1/3. And now, integrating, I have letter base to number power, and the number power is not -1. Add 1 to the exponent, divide by that. So that's 1/3 x cubed plus x. And we still need to evaluate from -1 to 2. Then we have our 1/3 times, plug in the 2, so that's 1/3 times 2 to the 3rd plus 2. And then minus, plug in the -1. 1/3 times -1 to the 3rd plus a -1. So that gives me 1/3 times, remember your order of operations. So I have 2 cubed, which is 8 times a third, so that's 8/3 plus 2. And then order of operations still, -1 cubed is -1. Times a third is going to give you -1/3, but minus -1/3 is plus 1/3. And then for this last part, I plugged in a -1 in for my x. So plus a -1 is -1, but I'm going to subtract that -1, so that's plus 1. Now, I always wait until I see what I can combine like terms before I get rid of my fractions or even build to get common denominators. Because here, look, you have 8/3 plus 1/3. Well, that's 9/3. So that's the value of 3. And then 3 plus 2 plus 1, altogether, that's a 6. And 1/3 times 6 is 2. So my average value of that f of x equals x squared plus 1 on the interval from -1 to 2 is equal to 2. So thank you for watching my video. I hope that you have found it helpful in finding your average value of a continuous function on a closed interval. And again, if you needed a little bit of the background of why this is true, you can go look at my video on the mean value theorem for integrals. And if you needed a little bit of a refresher on how to find indefinite integral values or even how to find antiderivatives, I'll leave some links for those videos in the description of this one as well.